Here are two examples for you to try. The first one we have 6y over y plus 5 plus 1. And the second one we have 2 over x squared plus 4x plus 4 plus 1 over x plus 2. So pause this video, try out those, and then we'll compare notes on the other side. Okay, we're going to need a least common denominator here for the first one. We have this case of a single number hanging out by itself with no denominator. Well, we put a 1 under that, right? Because every number has a denominator, sometimes it's just 1. All right, and now we can look at our LCD. We take the y plus 5 from our first one. We just have 1 for the second one, so we don't have to add anything there, so our LCD is y plus 5. Okay, so let's go ahead and add that in. So we put that in. We're good to go in the first term. Our second term, we need the y plus 5. Y plus 5 over y plus 5, because we're just multiplying by 1. This gives us, now we have one single denominator here, y plus 5, and then we have 6y plus 1 times y plus 5. Well, 1 times y plus 5 is really just y plus 5. We can combine like terms here to get 7y plus 5 on the top. And on the bottom we have y plus 5 left over. Note that we cannot cancel the 5 and the 5. Don't do that. What I just did was wrong because we have pluses that are not in parentheses. The general rule says if you have pluses or minuses that aren't in parentheses, do not cancel. So this is our final answer here. No canceling on that one. Okay, let's tackle the second one here. You want to factor first. Well, x squared plus 4x plus 4, this is a perfect square trinomial. So I don't know if you saw that or not, but this is really x plus 2 squared. If you don't want to go straight to the x plus 2 squared, you can factor it down. You'll factor it to x plus 2, which is indeed x plus 2 squared. So let's try for our LCD here. We take the entire first denominator, so x plus 2 squared, and then we add in anything we need extra for the second denominator. The second denominator is x plus 2, and that's already included in the LCD. So we don't need to add anything extra for the second denominator. Thus our LCD is x plus 2 squared. Let's go ahead and fix it up here. So our first denominator is good to go. Our second one is missing an x plus 2. Okay, if we add in an x plus 2, that'll make it x plus 2 squared down there. We always have to do the same thing to the numerator that we do to the denominator, because really we're just multiplying by a ginormous 1 here. Some people write this out as a huge 1, right? I think that makes it a little hard to follow, so I'm not going to keep that in, but you get the idea. Okay, so that gives us 2 plus, well, 1 times x plus 2 is just x plus 2 all over x plus 2 squared. And then this gives us x plus 4 over x plus 2 squared. No cancellation for that one either.